The information in this video comes from thorough research. Please share your thoughts on the video, the timeline, and the butterfly effect in the comments. We'd love to hear what you think. When the present determines the future, but the approximate present does not approximately determine the future. Edward Lorenz. The timeline and the butterfly effect, an exploration across science, philosophy, and culture. Human beings have always been fascinated by the passage of time and the complex interplay of cause and effect. These two notions, time and causality, are deeply embedded in our understanding of the universe, our daily experiences, and even our narratives. In the modern age, these concepts have evolved into sophisticated scientific models such as timelines and captivating theoretical ideas like the butterfly effect. The term timeline denotes a sequence of events in chronological order, while the butterfly effect suggests that small changes in initial conditions can lead to vastly different outcomes. This paper seeks to examine both the timeline and the butterfly effect in detail, spanning scientific, philosophical, and cultural domains. We will explore how these ideas have shaped our understanding of reality, altered our perception of choice and fate, and inspired countless stories across media and literature. The concept of timeline. A timeline is a linear representation of events arranged in chronological order. It is a fundamental tool in history, education, and project management. In science, especially in physics, a timeline represents the sequential progression of events in time. A timeline can be as simple as a list of dates or as complex as a multidimensional graph mapping space-time events. In personal life, people create timelines to mark milestones, birthdays, graduations, marriages, careers, and other major life events. These personal timelines help individuals make sense of their own existence and plan for the future. In broader contexts like history, timelines help humanity track civilizations, wars, discoveries, and revolutions. In digital media, timelines are interactive and allow users to scroll through events, manipulate data, and even simulate outcomes. This integration of technology has revolutionized how we perceive and analyze temporal sequences. Historical evolution of time perception. The perception of time has changed dramatically over the course of human history. In ancient civilizations, time was largely cyclical, tied to the patterns of the moon, sun, and seasons. The Mayans, Egyptians, and Hindus conceptualized time as a repeating cycle. In contrast, Judeo-Christian thought introduced a linear timeline, starting with the act of creation and culminating in an eventual end or judgment. The Industrial Revolution marked a significant shift in time perception. The invention of the clock and the demands of industrial schedules made time more regimented and linear. People began to live by the clock rather than by the rhythms of nature. In the 20th century, Albert Einstein's theory of relativity further transformed our understanding of time. Time was no longer absolute but relative, depending on the observer's frame of reference. This new perspective opened up possibilities like time dilation and the curvature of space-time, which are crucial in modern physics. Timeline in classical and relativistic physics. In classical Newtonian physics, time is absolute and flows uniformly for all observers. It serves as a universal background against which events unfold. This model supports a straightforward and linear timeline, where past, present, and future are distinct and immutable. However, Einstein's theory of relativity challenged this notion. According to relativity, time is intertwined with space to form a four-dimensional fabric known as space-time. In this framework, the timeline of an event depends on the observer's velocity and gravitational field. Two observers moving at different speeds may perceive the order of events differently. This has profound implications for the concept of timeline. It suggests that the universe does not have a single, absolute timeline, but rather a multitude of interwoven timelines shaped by observers and their relative positions. Timeline in philosophy and religion. Philosophers have long debated the nature of time. Plato viewed time as a moving image of eternity, while Aristotle considered it a measure of change. St. Augustine famously said, "What then is time? If no one asks me, I know. If I wish to explain it to someone who asks, I do not know. In religious traditions, timelines often serve as frameworks for divine plans and eschatological beliefs. Christianity, Islam, and Judaism view time as linear and directed toward a divine end. In contrast, Eastern philosophies like Buddhism and Hinduism perceive time as cyclical, involving birth, death, and rebirth. These philosophical and religious views influence how people perceive events and make decisions. A linear timeline suggests progression and goal orientation, while a cyclical timeline emphasizes recurrence and balance. What is the butterfly effect? The butterfly effect is a concept in chaos theory which suggests that small causes can have large effects. The term originated from a metaphorical example. A butterfly flapping its wings in Brazil could cause a tornado in Texas. This idea underscores the sensitivity of complex systems to initial conditions. First introduced by meteorologist Edward Lorenz in the 1960s, the butterfly effect challenges deterministic models. It implies that even if a system follows deterministic laws, predicting its future becomes practically impossible due to the exponential growth of tiny uncertainties. The butterfly effect has found applications in diverse fields, from meteorology and ecology to economics and sociology. It has also permeated popular culture, appearing in films, books, and television shows. The origins of the butterfly effect. Edward Lorenz discovered the butterfly effect while working on weather prediction models. In 1961, he ran a computer simulation with slightly altered initial conditions, changing just a few decimal points. To his surprise, the outcomes diverged dramatically. This discovery laid the foundation for chaos theory. Lorenz published his findings in a seminal paper titled Deterministic Nonperiodic Flow, highlighting how deterministic systems could behave unpredictably. The term butterfly effect gained popularity after a 1972 talk titled Predictability. Does the flap of a butterfly's wings in Brazil set off a tornado in Texas? Since then, the butterfly effect has become a symbol of unpredictability and interconnectedness. It shows that systems can be deterministic in theory, but chaotic in practice, especially when they involve numerous variables. Chaos theory and its connection to the butterfly effect. Chaos theory is a branch of mathematics and physics that studies systems that appear disordered but are governed by underlying patterns and deterministic laws. These systems are highly sensitive to initial conditions, making long-term predictions difficult. Examples of chaotic systems include weather patterns, planetary orbits, population dynamics, and even traffic flows. The butterfly effect is a key feature of chaotic systems. It illustrates how small differences in the starting point of a process can lead to vastly different outcomes. Chaos theory has revolutionized our understanding of complex systems. It has shown that linear models are insufficient for capturing the nuances of real-world phenomena. Instead, nonlinear dynamics and feedback loops must be considered. Scientific examples of the butterfly effect. Numerous scientific examples demonstrate the butterfly effect. Weather forecasting, slight errors in temperature or pressure measurements can lead to vastly different forecasts, making accurate long-term predictions nearly impossible. Ecological systems. Introducing or removing a single species can disrupt entire ecosystems, as seen with invasive species like rabbits in Australia. Financial markets. Small investor decisions or rumors can lead to massive market shifts, exemplified by flash crashes and bubbles. Epidemiology. Minor variations in contact rates or mutations can significantly affect the spread of diseases, as seen in the COVID-19 pandemic. These examples highlight the practical relevance of the butterfly effect in understanding and managing complex systems. The butterfly effect in human history. Throughout history, small and seemingly insignificant events have often led to major consequences. Consider the assassination of Archduke Franz Ferdinand in 1914, a single act that triggered a cascade of alliances and hostilities, ultimately resulting in World War I. Another example is the invention of the printing press by Johannes Gutenberg, a relatively localized technological advance that sparked a cultural revolution across Europe. Even in personal history, minor choices can have monumental effects. A decision to attend a particular university, meet a certain person, or read a specific book can alter the trajectory of one's life. These personal butterfly effects underscore the unpredictability and interconnectedness of human experiences. Understanding the butterfly effect in history allows us to appreciate the delicate web of causality that shapes events. It teaches humility in planning and foresight in decision-making, acknowledging that even small actions can produce far-reaching consequences. Implications for time travel and alternate timelines. The butterfly effect has profound implications for the concept of time travel and alternate timelines. If tiny changes in the past can drastically alter the future, then time travelers must be exceedingly cautious. This concept has been extensively explored in science fiction, where characters who alter a minor event in the past return to find a dramatically different present. Popular media, such as Back to the Future, The Butterfly Effect, and Doctor Who illustrate how alternate timelines might branch out from single events. These fictional portrayals raise philosophical and ethical questions about free will, determinism, and the consequences of our actions. Scientifically, theories like the multiverse hypothesis suggest that all possible timelines exist simultaneously in parallel universes. This view supports the idea that every decision creates a new branch of reality, a concept aligned with both the butterfly effect and quantum mechanics. If you have any experiences related to this topic, be sure to share them with us. Until the next episode, be mindful of the energies around you.